So LUCID is a cross-disciplinary graduate training program. I think there are lots of elements of our daily lives where people are interacting with and learning from computers. And on the flip side, we're trying to use computers to learn from masses of data that are produced by human behavior.
Our program draws on 4 pedagogical principles. Our students have their homes in one of the core disciplines of our program, like computer science or educational psychology. And we want to make sure that the interdisciplinary training that they receive as part of our program does not increase time to degree. So therefore, our students work on interdisciplinary projects together with students and faculty from other disciplines. But rather than expecting our students to master the other disciplines, we want them to learn just as much so that they can productively collaborate within those research teams.
I get to interact with professors from other disciplines than mine. So if that was not the case, I will just focus on research from only my specialty. Right now I can actually talk with people from psychology and educational psychology, and that gives me a different perspective about what can be done with the things I'm learning from my discipline.
I feel like I get a perspective on some problems that a lot of my classmates in other labs might not. I get to work with some folks in psych, and it's always nice from like a theory machine learning perspective to actually see the things that you work on have some real impact. It's also challenging. We have 2 different sets of jargon, and that is a constant source of worry. So, for example, one of the biggest topics in my lab is that we'll focus on what's called active learning, which is also a field of study in educational psychology, and the two have essentially nothing to do with each other. So one of the challenges, especially early on, was like kind of learning enough about each other's disciplines to the point where we could actually discuss.
Many PhD students choose not an academic career, but instead take positions in industry. Therefore, our goal is to engage students from the start in research that addresses practical issues that are relevant to industry. And we have industry partners ranging from print media to edtech companies, and we collaborate with them to develop problems that students can work on during a year-long internship that they do here on campus, potentially followed up with a summer internship at the company. And this ensures that students learn how to do research that is applicable to industry.
Obviously, this is going to be super valuable if they go off to work for people like Facebook or Google or Apple.
Here's an example. We've been working with Bob Mankoff from The New Yorker, who is the cartoon editor there. And as you may know, they've run for many years a caption contest where they provide a graphic showing a cartoon, and they solicit funny captions from people all over the country.
And they have to find the funniest one. How do we do that?
Computers cannot determine what's funny. They have no idea. People can do it very easily. You just read the caption, you know, is it funny or not? And for many years, there was one lone internship in Bob Mankoff's office who was trying to do this.
The way we do that is with this active machine learning system.
The machine will serve up a caption for a given cartoon to a human user who can decide whether it's funny, not really funny, or unfunny. After collecting a bunch of these judgments, we can run some statistics on those judgments, and we can pretty quickly rule out captions that are not at all funny, which means that we can very quickly zoom in on candidates for being relatively funny. And so really with just a few minutes of this kind of behavior, we can very quickly bubble to the top the 100 or so funniest captions out of, say, 10,000 submissions to the contest. And this kind of a system, I think, exemplifies the potential of human-machine collaboration, the kind of research we're trying to do at LUCID.
It's being used every week by The New Yorker. I can more easily relate to problems that psychologists and neuroscientists and biologists that they see in the real world.
Our mentoring model is project-centered, so our students work on real-world research projects and receive guidance to learn the knowledge and skills they need just as they're used in the project. Each project is co-led by at least 2 faculty from different disciplines, and these faculty jointly mentor the student on the project.
Professors are actually helping me out a lot. I work with Professor Jerry, but he's not directly into psychology, so the different learners we use are not actually specialized for humans. That's where team comes in. Team can actually tell me, okay, this model does not make sense for a human.
In addition, each student is teamed up with a peer mentor who is slightly more knowledgeable or has complementary background and skills. And this approach ensures that students can engage in self-directed, project-driven learning while receiving guidance from multiple people with a variety of disciplinary backgrounds.
And I think it's actually been pretty important for my growth. While Rob is wonderful to talk about intuition with, sometimes you kind of need someone who can like explain the math and just like really work through the nuts and bolts. And in that regard, like a student who's perhaps going through that or like went through that pretty recently is a great source of collaboration.
I think students are in a better position, whichever side of the interdisciplinary collaboration they come from, they're in a better position to understand what that new person on the other side of the fence might be struggling with, because they were doing that same struggle not so long ago. And sometimes with professors it's a little harder, certainly hard for me to even begin to guess at what a psychology student knows or understands and what they don't.
So now I have one advisor and 3 mentors.
As researchers, we need to be able to communicate to the public why our research matters. And we train our students in using social media to communicate their research findings in a way that is accessible to non-scientists. And we provide opportunities for our students to connect with local communities here in Wisconsin, for example, through science fairs.
Unfortunately, we see some students graduate who have excellent technical skills, but have a difficult time communicating those skills or their ideas or their approaches to non-experts. But when our quantitative students are working with psychology students, it puts them in a position where they regularly need to put their ideas into terms that are understandable to other scientists and in other application domains.
We want our scientists to be able to go into the elementary school and give the kind of kernel of what's important about their work to a 5th grader. We want them to be able to talk to members in government and explain why the use of tax dollars is so critically important for advancing this kind of science. We'd like them to be able to go to public science fairs or to TED Talks and just express to the general lay public who's interested how incredibly cool and interesting this area of science actually is.
And we hope that besides training our own students in communication, that this allows us to inspire a broader interest in using data science to look at how people learn and how people think.